And we'll have.
Hi everybody, this is Joanne with Read Science, and I'm joined again today by my co-host Jeff, and we are talking about water and rain with two amazing authors who have published books by approximately the same titles. And I look forward to this simply, if for nothing else, by guilt of association. My children are becoming completely obsessed with water. My oldest is a grad student in atmospheric sciences, and my next oldest is looking at grad school for hydrogeosciences.
Yeah.
And with all the water, how important water is in the entire world, I think they will be employable for the rest of their lives. This makes me very happy. So without further ado, I'm going to allow Jeff to introduce our first guest, Cynthia.
Cynthia Barnett, welcome to the show. She's the author of one of our books today called Rain, A Natural and Cultural History. She describes herself as an environmental journalist, and she's made fresh water her subject for some time, as well as the subject of her 3 books so far. Her previous books have been Blue Revolution, Unmaking America's Water Crisis, and Mirage, Florida and the Vanishing Water of the Eastern U.S., and both have been recipients of awards and many accolades. Rain, which you can see right here, is one of those rare types of books that we admire here at Read Science. It's a science book that includes poetry and art. It's a cultural history that integrates science naturally into its narrative. Both good things. She joins us today from Florida. Welcome, Cynthia.
Hi, thank you for having me on. I'm so excited to be here.
Welcome, Cynthia, and I will give a brief introduction for Alok, who, Alok, I have discovered apparently you are well known for your hair. I keep getting people saying they're, retweeting. Alok's hair is retweeting, so I don't think that's what you want to be known for, but, there are worse things. So
I'll take anything.
Alok Jha is a journalist, author, and broadcaster focusing on stories about science. He is a science correspondent at ITV News, which would be in the UK, and he graduated from the Imperial College of London with a degree in physics, and then he spent a decade at The Guardian and made programs for the BBC. His book, we don't have it, Alok might need to hold this up for us, is The Water Book. And this book is great because it talks about the wonder of water, about the chemistry and the astronomy, what we know about what we need for life. And very interesting story. And if anybody out there recalls, when there was a science ship stuck down at the Antarctic last in January 2014, he was on there. And we were all watching, biting our nails. Will they ever break free? Well, he's here on our Hangout, so we know this has happened. Welcome, Alok.
I'm very excited to be here. Thank you very much for having me.
We're glad to have you. All right, Jeff.
You've given us so many topics under the, well, if you will, umbrella of rain and water to start with that I couldn't decide what to go with, but I thought maybe there is in the U.S. at least a big story. So, here's an essay question ripped from today's headlines about, I want to talk for a bit about the drought in California, which has become very severe and a very important topic, and draws in all the nature questions, the political questions about water, geological history, all sorts of things. But I've noted we have a strong tendency to think of something like this drought as some anomaly, something that's gone wrong. Perhaps we've upset the gods. But when we look at long-term trends, at geological time, this is just part of the big picture, isn't it? Now, I want to ask
Yes.
Cynthia first for your thoughts.
Yeah, so I think the California drought is part of the big picture, but the big picture in climate history, but it also has to be seen in the big picture of climate change. So you're right, this is an epic drought, and I should say, I think it's kind of weird that we call it the California drought. Right? Because the Colorado River has been in severe drought for 15 years. You know, we see wildfires are blazing around parts of the West now, and these topics don't stop at state lines. We're all
We may have lost Cynthia there for a little bit. I don't know if she can still hear us. But mentioning the Colorado River brings us into talking about the drought in the Colorado River and the rise of farming in California and how that has put so much stress on the water sources, and then why there are so many people around Nevada, the Southwest, California, and all along the Colorado River who are putting a severe, severely taxing that as a resource. And maybe until we can get Cynthia back. Alok, would you like to comment?
Well, I'll say one thing about the environmental lack of water. As a reporter for a long time, I've covered and been interested in drought, in water resource, as the larger climate change story, as Cynthia mentioned it. It is part of that. All environment stories are connected in that way, and climate change seems to be the sort of grammar of environment stories now, doesn't it? Everything is related to that in some way, and of course, this is one of those things. So, and it's not, of course, I mean, the Californian drought is not something that, in a sense, we have focused too much on in this part of the world. In Western Europe, Southern England, even in a very parochial way, we lack water almost every year during the summer for a certain number of days. When I was a kid, I remember specifically hosepipe bans. So we were not allowed to use hosepipes to clean our cars. I remember one summer, my mum sort of saying to us, "Can you just wait for the police down the road in case they come? I need to wash your dad's car." So this was ever since then. I knew that water was this very precious resource. As you grow older, you realise why. And California is a good example of this. It's not actually necessarily because you don't have enough water. I mean, the Great Plains of the U.S., you're sitting on one of the biggest aquifers in the world, one of the most ancient aquifers, the Ogala. There's plenty of water in the United States. It's just used very badly, and California especially takes it from other places, grows lots of things, and exports all of its own water as food elsewhere. So actually, there are municipal problems. Obviously, there must be problems with pipelines and all these things too. I very closely looked at the droughts in Sao Paulo that are going on right now, and this has been going on for a year now. You've had riots on the streets, and again, there is a climate aspect to it. The deforestation around those parts of the Amazon means that the water in the air just isn't there anymore, which normally would have flowed to that part of the world and watered the reservoirs. And so you have these empty reservoirs. But it's not only that, it's the fact that there's been corruption, there's been bad pipelines, people aren't using water properly, they're drilling into the aquifer there. I mean, this is a very rich city, Sao Paulo. It's got poverty too, but it's very rich. California is a very rich place. And so I think these stories suddenly have brought water into our world, whereas in the rest of the world, it's been a big issue for a very long time. It's almost like they have brought this story out to everybody. Until now, no one else seems to have paid attention to it, apart from maybe people like me and Cynthia and you guys who probably obsess over it a little bit. But the rest of the world hasn't cared until now. Do you think?
But we can go back to Cynthia now, still on the same thing, but what's going on in California has brought the story up enough at the same time that we're having an awareness and a shift in understanding about climate change, El Nino, various differences between climate and weather, all sorts of stuff that people are thinking about for the first time, I guess.
Yes. Guys, did you hear the answer about California, or did you lose me before I finished what I was saying?
We lost you, and Alok jumped in with his observations from having written some stories, even though his current book is not so much about it. He talked about the Ogallala, and then he also talked about Sao Paulo. So that's my brief interpretation of what he just said.
Okay, so you didn't hear any of the answer about California, and I'll catch up. Okay, what I had said, and I'm sorry about the technology breakdown on my end, but I think twofold. For one, yes, we can see it in the big picture of climate history, We know that the drought going on now, we have seen those sorts of droughts in many thousands of years in climate history. But the interesting thing about California and the United States for water development is that we developed the great water works of the West during what was the wettest time in the entire millennia. So I think it has both the climate angle and the population angle. We have had droughts like this, but we haven't had them in a time when we had this many people, drilling this many holes in the ground.
How do we get people to understand the longer view on climate over geological time, and how in that bigger picture our current sweet spot is rather anomalous?
Yeah, I'm sorry, I've lost you again, Jeff. I'm wondering if you guys should go on.
We'll just keep talking.
If you should go on without me. So you're hearing me okay?
Yeah, well, it breaks up now and again, but we can hear you. It should be okay. It should be okay. So let's since Cynthia is having some technological issues, I'm going to sort of jump to Alok and a little bit about briefly. I didn't mention this before. If you are looking for his book, it is currently not available in the United States. So I just wanted people to know that. It's only in the UK, but he is shopping it around. So if you know someone who wants a book that talks about, water from more of a chemistry perspective, like how is it so weird? And in fact, why don't I let you describe what your book is about?
Well, okay, so where do I start? So I think you can, just to say about the availability thing, I think you can get it on Kindle, so you may be able to do that, and I think it should be out in the States by next year. I'm fingers crossed. So they should be there, and just as a sort of thing, American publishers seem to always want Americans in the book. So if you're a British writer, that's what you have to convince them. There are lots of Americans, as if like the rest of the world doesn't exist. But fortunately for the American audience, there are many Americans in this book, so that's okay. I like Cynthia, like all of you, I'm interested in water as a resource. I'm interested in the fact that we're not managing it properly. I'm not I see as an environment reporter myself how we don't manage and how it's affecting the world. And in a complete sort of reverse ferret on that front, I decided I wasn't going to write about the environment in this book, because it's such an important subject. It's this by itself, and there are many, including Cynthia's, that you can read about this. And I felt that if I was to cover what I wanted to cover, which was the chemistry, the origins of water, what it does inside you, why is this substance that has managed to create life, and why we do spiritually revere it, scientifically are a bit afraid of it, and why it's managed to do all these things, and yet remain innocuous as a sort of layer in our lives that we don't really pay attention to. I wanted to examine that tension, and I thought that if I was to cover too much of the environment and resource aspect of it, that's what everyone would focus on, which is a good thing to focus on, but for me, I felt I wanted to almost not mention that, and I do mention it a little bit. So I thought what I wanted to do is tell the story, essentially, of water molecules, where they come from, where they're made, how they get to Earth, how they then stay on Earth and create the conditions for life, the only life that we know of in the universe right now, how that life then tries to understand what this substance is, first of all through myths and legends and just survivability. We always spring up cities and settlements near rivers and coastlines. We talk about water myths in every culture. Every culture has some sort of flood myth of some sort. In many cultures, the entire universe comes from water. In Genesis, the God moves above the still waters, of course, and things are all made from water. We've written poetry about it for thousands of years, and then only in the past few hundred years have we started to try and understand it through science. And because it's a common material, it was one of the first things history as people try to understand what this stuff was. And only in the 17th and 18th century do we discover it's not an element of nature, it's actually a molecule, which I think is quite late. Only in 1870 do we know that it's H2O. I mean, all of this stuff's quite new information, relatively speaking, in the history of humanity, given how common and popular this stuff is. And then you get to this point where, actually, not only is it common, not only do we know now that it's a chemical, but it's so strange. It doesn't do any of the things normally. Like, why is it a liquid? It doesn't make sense that it's a liquid. Why does it dissolve everything? It's the universal solvent that all the alchemists were looking for. It was right there in front of us. And if you don't believe me, this is the substance that has carved out the Grand Canyon over billions of years. So it can destroy everything over a long period of time, given enough time. And so I wanted to examine that sort of stuff that's there as a layer in all of our lives, but which we just ignore on a constant basis. And then once it creates life, I wanted to look at what it does inside you. Why is it you drink water? Why do you get thirsty? What is it doing inside you? And that is a wonderful story in its own way, of the fact that it moves energy around. It creates your cell membranes. It makes sure DNA and proteins are working properly. It's at the center of the most important chemical reaction on Earth. The way that all of life gets its energy is through photosynthesis, and that reaction begins by light splitting an atom of a molecule of water. And then I wanted to finish by looking at, look, we've done all of this stuff. Now let's go. Now we're looking for water in space. And I've been a space geek all my life. That's my thing. I'm a physicist, and I wanted to be an astronaut when I was a kid. But I realized that to be an astronaut, you have to be American, unfortunately. Back when I was a kid. So unfortunately, that was never going to happen for me. So being a journalist was second best, basically. I've managed to go to a lot of NASA sites as a result, and I was privileged to go to many NASA sites to research this book, and talk to them about their work in astrobiology. And you can see, actually, I think you can argue that all of space exploration, from the beginning of NASA onwards to now and beyond, the European Space Agency, it's all about looking for water in different places. And that's all they do. And continuingly, as we look at exoplanets, they look for water in those places. If you find water somewhere else, you get very excited. Why? Well, it's because of what it's done on Earth. And in a sort of circular way, what I wanted to say was, look, we're looking for these bodies of water, oceans on other planets, exoplanets, and within 20 years we'll know whether there's oceans of water elsewhere, and we'll be able to image them. And that's a remarkable achievement. And why is it that we're looking for those things? It's because if we find an ocean planet somewhere in space, what we're looking at is the Earth 4 billion years ago. And why are we excited about that? Well, it's because look what happened when the Earth was an ocean planet with no life on it. Look what water did on this planet. It might happen there too, and that was my sort of circular argument for the whole thing. And then, of course, water goes off into space and continues its adventures. We're just a pit stop on the way.
Well, on the matter of origins, until I read what you wrote about it, Alok, I don't think I'd realized how much water there is in space. There's
amazing,
a lot
isn't
of
it?
water, and then and this is very similar because Cynthia also talked about origins. You both did, with different stories to tell. Unfortunately, there's so many stories. And I had one quotation I wrote down from near the beginning where she said, virtually all the rocks that made Earth had water locked inside. And I'd never asked myself until then, or worried about where all the water on the Earth came from. And now I know. So, are you hearing me, Cynthia?
I can hear you now, and I think maybe if you didn't think about that earlier, it's because some of this research is relatively new. We all grew up, I think people our age grew up with this, maybe it's sort of a Goldilocks myth that we were an exceptional planet and we're the blue marble and only we were blessed with water. And as Alok says, the reason we're so fascinated to find water out there is because it means we would be finding life, right? And so I think maybe if we don't think that way about the water out there, it's because we grew up with the idea that we were quite exceptional on this blue planet, and it's so exciting to think that perhaps that's not the case.
But we still maintain the myth that, okay, maybe there's water every place, but we can hold on to the fact that whatever the creation of life was some incredibly unusual spark of an event. But both of your writing, and Alok particularly, is talking about what we're learning about self-organizing systems and how life works, and talking about the cell. And we're finally starting to see light at the end of that tunnel that says this is how life could arise spontaneously, just as I think Alok's theme in that section was because of the properties of water, it almost inexorably leads to that.
Well, I would say that's not I'm an optimist, and I think that if given what water has achieved, if I can give it, if I can say that, and I by the way, I talk about water achieving things in a slightly self-conscious way, only because I've had so many questions from people saying, "Oh, does that mean water has consciousness?"
Yes.
And that homeopathy is real. So I've had to do a lot of discussions where I had to politely say, "Look, that's not at all what I meant by this. It was just a narrative device." But anyway, given what water has achieved, because of its profoundly strange chemistry, and they're very simple rules, and we know from chaos theory, we know from chemistry that very simple rules can build very complex things. It's done that over a very long period of time here on Earth. And if we think that almost every body on the solar system now has water, and many of them we're discovering have oceans, so Europa, Ganymede, these moons of Jupiter and Saturn, which are so exciting, and Enceladus, they have oceans of water. Enceladus has a hot ocean sitting on rocks, which is the perfect sort of way you would start life. So, I'm terrifically excited that, all this time there's been microbes over there, and some point soon we're going to go and find them.
Yeah, it's, Alok, I was reading your book on, I read it on my phone because you were kind enough to send a PDF. Because since we couldn't get a hold of your book straight away, and I'm anticipating it because the cover looks amazing on top of actually having a physical book. But I'm reading it on a plane, and I have a friend looking over my shoulder wondering, what am I reading? So it's like, and it was just so fascinating. And the fact that someone could be reading over my shoulder on a tiny phone, you know what it means? You've written something really fascinating. So, there were things in there I'd heard, and it's always nice to hear again, but then there were things I was like, I didn't know that before. And the whole part of Enceladus, I was like, oh, that's what those articles were about, where I read the headline and I skip past, right? So it was very happy to read the book and to learn the new things. And as a biologist, of course, it's so fascinating. They make us take chemistry and physics and talk about water, but not to the extent that you covered it, and to really emphasize the importance of water. Or maybe it just becomes all background. You just know everything's happening in an aqueous environment.
Biology becomes this very interesting subject outside the Earth all of a sudden, because you're normally stuck on Earth, seeing the things that are happening here. So there's obviously that very interesting field of research in the past decade or so, looking at where life started on Earth. So where did the first cells come along? Were they hydrothermal vents? Were they somewhere else? It gets into real chemistry and physics type questions, but biology has to put it all together. You can't just have the chemistry and physics. And then suddenly this science becomes extraterrestrial. So we need to understand biology if we're going to really understand what a habitable environment means. And then there are all sorts of questions about what you mean by habitable. Do you mean habitable for our life? Habitable for some other life? Is water the only thing? These are all sort of unanswered questions, but they're very, very new. I do believe that NASA is funding sometime in the decade and drill through the ice what's in the water. That's got to be one of the most exciting projects that exists right now, as far as I'm concerned. I feel like we're getting very far away from Earth's water, but that's it's exciting to me.
I'm in the mood for a moment of comic relief, so I made some notes from Cynthia's book, and one fact that well, a few facts. First of all, the first TV weathercast presenter, the date is 14 October 1941. The place is New York City. The first presenter was Woolly Lamb, which is a little hard to say clearly. And I feel like looking for archival footage on Woolly Lamb. And we also have the note that the Times of London was the first to print a daily weather map in 1875. Although, quoting you, journalists were eager for weather news, which was the #1 interest of most of their newspaper readers then. But the background on that was here some facts from 1860 in Britain, that weather forecasting was, 3 things I wrote down, likened to astrology, that enraged the ship salvage companies, and I made a cryptic note that Robert Fitzroy killed himself in 1865. That meant something at the moment when I was reading it, but I don't know if I remember what. But weather forecasting did not start out as well as a noble profession, apparently.
Well, it's yes. Can you hear me? Okay.
Yes.
We can hear you fine, yeah.
Yeah, you're going in and out, but I'll answer that. I know generally what you were talking about and heard Fitzroy, and I feel so sympathetic to Alok trying to get an American publisher, because in exactly the situation he's gone through, British publishers do not believe that Americans can write about the weather. I dared to write about the weather and I visited London and the Met Office in Exeter and did a lot of reporting on British weather history for this book, and also had a hard time. It's interesting, it's sold to other publishing houses all over the world, but not in the UK, because they felt it was too Americanized. And
we love our weather here, yeah.
I know. And so luckily my publisher ended up publishing it in the UK, but because we couldn't find a counterpart there. But back to the earliest history of forecasting, the interesting thing to me is this shift that's happened. So in the early days of forecasting, the British saw it, or some British saw it, as rather voodoo. So Robert Fitzroy, who had been the captain of Darwin's vessel, the Beagle, had come back, and he was just a brilliant meteorologist, and gave the world forecasting. And of course there were other issues involving his suicide. You know, he was obviously disturbed, but it did not help that he was just being pilloried by many critics, including some of the ship salvaging businesses who didn't want to see forecasting, although he had many supporters, including in the media. On the other hand, the Americans didn't see forecasting as voodoo. We really loved it, and we got into it, and we had, just before the Civil War, we had forecasting stations, about 500 of them all over the country, run through the telegraph lines, but that network crumbled in the wake of the Civil War. So I think this shift is interesting, because in those many years ago, the British were skeptical. The Americans, accepted it despite the uncertainty. And now when you look at climate change, I think British audiences are, more trusting of scientists and accepting of the uncertainty and the story of climate change in a way that hasn't happened in the United States. So that's kind of an interesting shift.
Speaking of the climate change and sciencing, you put me in mind of a fascinating story that Alok told. And I don't know if I made the right note of it, but 150 years ago we had this ship, the Challenger, that's what it is, the Challenger, going around the world, making measurements of the ocean, of ocean temperatures and ocean depths. And that was interesting enough, science and forward-looking, even though it was hard to see it maybe at the time. But that ties in with a climate change thing, because some people claim to continue to be skeptical about climate change because they feel like that what we know about climate change is all based on just a few suspect sources, and don't realize the variety of sources, because you told the story of using Argo probes and other things, and then a new ship to reproduce those, to remeasure those results at those points, and that gives us a direct look at how things have changed. Maybe you can tell that story more clearly, because that ties into so many useful things.
As it was, I mean, the HMS Challenger was this remarkable expedition. As always with these expeditions by British sort of Navy people, it's filled with aristocrats and others persuading important members of society to donate money to travel the world, essentially, and catalogue most other Britain anyone. It was just a case of going around the oceans for about 4 years and mapping, as you said, currents, temperatures, the sea life. And it was one of the first times that it was the first time this had happened. This was the 19th century, and until the 19th century, of course, we had been traveling the oceans for hundreds of years, but no one had thought that there was much in there. It was just beyond a few. No one really knew what was down there. Occasionally something would pop up, but no one really had a clue. So this was all about working out what was in the oceans. And it was at that point we started to discover the oceans are such an important part of our global ecosystem, global weather pattern system, energy transport, all those things. And it's the beginning there. And given how much of the world is covered in ocean and sea, it's weird to me that we've only been bothered about it for that long. But yes, so what they did was to measure very carefully the temperature and currents at different times of the year in about several dozen places around the world, and they spent 4 years doing this. It took them another 20 years to write up their scientific findings. There was so much data, and they brought back hundreds of jars of specimens and things. Fast forward about 150 years, and you've got these oceanography. The challenger for me, and I would argue for a lot of people, is the beginning of oceanography. That's where the science of oceanography begins. Being interested in the oceans is more than just how do you get across the ocean to take your basket of spices or goods or whatever. It becomes a physical science in its own way. And 150 years later, oceanography is very well developed. A lot of it is done by robotics now. We have these amazing probes, the Argo program. There's about 3,000 of them that just float around the ocean currents, and all managed by, I think, University of San Diego. I might be misremembering that, but they all sort of communicate to this one portal at the University of San Diego, at Scripps Institute, I think, and they have almost real-time data coming from these 3,000 probes, and then other oceanographic vessels will replace the ones that have lost or the batteries have run out. So these things go round and around the world, and on ocean currents they surface every so often and transmit data back via mobile phone signals, and then come back down again. I mean, they're incredible. So you don't have to go and physically measure the temperature of the oceans, because if you think about it, 150 years ago, the way oceanographers worked was literally take a bucket of water and put a thermometer in it to work out the temperature. And can you imagine how hard that would be? Anyway, so 150 years later, the Argo program has all this data, and they were able to pinpoint specific locations that Challenger had been in 150 years earlier, and also track the seasons too, and recreate the Challenger expedition using modern data. And they find that the temperature of the ocean in the first few meters of the depth has risen as they predicted. As all the models show, it's risen by about 0.7, 0.8 degrees, almost a degree in some places. I mean, that's a massive amount of energy in the ocean. One of the other things in my book is all about how water bizarrely can store a lot of energy. That's why it's so good for life, because the temperature of water just doesn't go up or down that much. Even if you whack loads of energy into it, the sun can be beating all summer long, and your local lake will only get a little bit warmer by the end of it. And it's kind of infuriating in some respects, isn't it? But it means that life is buffered. It means that we don't have spikes in temperature. It's good stuff to keep you at a sort of level. So the fact that it's the oceans, the entire world's ocean has gone up by 1 degree, I mean, that's just huge, huge amounts of stored energy, which we have done.
It was when I was reading about that, and for some reason it made me think of people who are usually treated comically, who lie awake at nights and can't sleep because they're worried about the end of the universe happening and how it's going to come. And it made me realize that the pointless thing that keeps me awake at night is what it is that might stop the ocean conveyor belt. Which sounds like one of those nonlinear, highly sensitive things. This might change by a degree over here. The conveyor belt shuts down. Suddenly things fly out of whack, and it's going to take 20,000 years to get them back into place. Because
you're worried about the day after tomorrow, aren't you?
Yeah. So maybe we should talk about weather. Cynthia, say some. I see you moving around, so you're with us for a few minutes.
I am. I'm with you for the moment.
I think it was Alok who said weather is basically moving water vapor around, or moving water around.
Yes.
The Earth, it's like, wow, it pretty much comes down to that, doesn't it? I mean, rain.
I love what he said about weather and about water and its goodness. And I just like to go back to the point about how we help people understand climate change on that long scale that you were talking about, Jeff. And I think water and weather are really the ways we will do that. So all the early impacts of climate change that are tangible, sea level rise for us here in Florida, the epic drought in California, whatever extreme weather and changing weather all over the world is happening. It's all manifesting itself in issues involving weather and water. And so I think water and weather will be the ways that we come to talk to the general public about climate change. And I think it's also the way that the shouting match over climate change in the United States will become a conversation. I teach environmental journalism at the University of Florida, and I talk to the students about this audience I have in my mind's eye. This audience is called the caring middle in my mind. And so, and that's really how I came to write A Book of Rain. I would go around the country talking to people about my water books, in libraries and sort of general audiences. And I figured out that even people who don't want to talk about climate change love to talk about the weather. They love weather. They love water. They're completely fascinated with these topics. So that sort of led me to the idea of writing an entire Book of Rain in the first place.
So water is the right catalyst for all these conversations, because it is so common, so familiar, so ubiquitous, and we understand so little. The everyday person, most of us understand so little about
and so important. Yes.
Yeah.
And so important, as Alok pointed out, to our religious myths, to our our cultural history, everything about it. I've just lost you guys a little bit, so I'll listen.
We can hear you. We can hear you.
Okay.
We hear you. So. Okay, so actually, Cynthia's book, being the natural and cultural history, it actually reminded me a bit of, I don't know, anybody out there read the book Rabid, but it was like talked about, like everywhere in every religious, text or stories or where we could find rain. So, we have literature, we have religious and spiritual texts talking about rain and everything else. And I remember the book Rabid talked about, where does rabies show up and everything. So I felt like there was some interesting parallels. It's like the format of your book in that. And Cynthia, I will mention one thing. So I listened to your book on audio, although if anybody ever picks up this book, and I understand Alex' books too, I don't know if you can see this, but her book shimmers. The raindrops are silver foil. And I hear Alex's book is the same too. But I have to say, if you listen to her book, and I don't know if you know this, and maybe you did this on purpose, but you make a lot of lists that are separated by commas. And, when this list goes dot, 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 and I was thinking, that sounds like rain. That sounds like rain. It's like a raindrop, raindrop, So I don't even know if she can hear to let me know that.
I can hear you. Joanne, I actually may have mentioned this to you. I didn't like the audiobook. I don't know if I should be saying that. I probably shouldn't. But I don't know about Alok, but I like to read my work aloud. I actually read aloud while I'm writing. That helps me edit, and so I have a cadence in my mind. And I didn't think that the audio book worked, and then there were some of the terms from India that were mispronounced, so that was painful for me. So try to buy the hard copy, guys, or read it on your Kindle.
Well, I found the audiobook to be just fine, and I felt like I think maybe when I read it, if I had read it and saw the list, I might not have thought of it like, rain, like a just repetitive rain. Whereas hearing it, that's what I heard in my head. So that was really neat.
Well, the poet Conrad Aiken called rain the syllables of water, which I think is my favorite line of poetry about rain. And it really, I like to think of rain that way. It really is the syllables of our water, isn't it?
It's interesting. That's very interesting. So I do want to shift a little bit to talking about your books, more as a craft, as a medium for communicating science, even though I know we could talk all day about, the topics within, because both of the books are big. Like, they're not gigantic, right? But they're big.
They're packed full.
They are packed full of information, so there's plenty to learn in these books. But actually, I will ask Cynthia really quick. So, and Alok too. So Alex says, the UK, we love our weather here in the UK. But my impression, and that's just because my son's in atmospheric sciences in grad schools, and he's studying climate issues. He's in Colorado State University. But we have so many well-known universities for studying the weather in Colorado, in Oklahoma, in Wisconsin and Pennsylvania, but so many concentrated in the west of the U.S. And any idea how that came to be, Cynthia, for instance? Or Alok, is there a place in the UK where people say, yeah, if you want to study atmospheric sciences, you go here? Any idea?
Well, I will mention, Joanne, that all of my precipitation data came from the National Climatic Data Center in Asheville, North Carolina. And Asheville, North Carolina actually houses the largest collection of weather data anywhere in the world. It's amazing to go. It's in this federal building downtown, and the basement is full of documents. They even have old ship captains' logs, dating back hundreds and hundreds of years. And it reminded me, Alok, of going to the Met office in Exeter and interviewing meteorologists there and seeing some of their amazing meteorological history. So it's true that we have a lot of great weather centers in the West, but I think there are, we have the National Hurricane Center in Miami. We have the like I said, NCDC in Asheville, North Carolina, a lot going on in Virginia and Washington. So it may just be the weather crisis du jour and who we're hearing from. We always hear from the tornado people in Norman, Oklahoma, when that's a big story. But I did say to Joanne, when I heard where her son was, I said it does always strike me as odd that we receive the annual hurricane forecast from Colorado. That is always a bit weird.
It's very strange. So, Alok, do you have anything to add about weather in the UK?
Well, weather, as you've all said, in the UK is like a daily conversation because it's so changeable here. And so this past week, it's all been about how uncomfortable this heat wave is. And news stories and newspapers will be full of the fact that there's people now on the beaches and things. It's hard to get across to you how ingrained and everyday this conversation really is in this country. If you ever want to talk to a British person, this is not actually, I'm not just making this up. If you ever want to talk to a British person and make them comfortable, just talk about the weather. It really is something we all know about. We can be inward looking and all sorts of things, but that's what we talk about. In terms of where, one thing that always strikes me kind of like makes difficult this science is that until recently, and we're used to modern scientific equipment measuring weather, measuring temperatures in the air or wind speeds or whatever in a sort of almost constant stream. You have a weather station somewhere, it takes all this data and feeds it probably through optical fibers to some supercomputer, and then there's the weather forecasters and atmospheric scientists and others are essentially writing programs with all this data, with hundreds and hundreds of data points from every place per second. But 150 years ago, 50 years ago, the way this was done by someone taking a thermometer and putting it into the ocean or into the air, writing down how much cloud cover there was, measuring the amount of rain in their back garden using buckets. That's how painfully difficult collecting information about the weather was, and to some extent still is. And so the amount of data and accuracy we have is getting better and better. And the place in Britain where this happens, of course, is there's two centres of weather research in Britain. One is the Met Office, as Cynthia mentions, which is down in Exeter. That's the National Forecasting Service. And also is one of the major climate research centres of the world, actually. So it runs one of the four. So there are, I think, 3 or 4 major climate models going on in the world, which have to which are all independent, but using similar data, which then you can then compare them to work out whether one's correct or not. And it runs the Hadley Centre in Exeter is one of those international centres, and there are obviously national centres in the US to do something similar. And then the University of Reading, which is just outside London, is the great atmospheric science meteorology place. So those are the places. I mean, there are other atmospheric sciences places. In my own college, Imperial College in London, there's an atmospheric sciences department, but it's very much a more theoretical, what does our atmosphere look like kind of thing, rather than the climate stuff. Although we do have a climate change department, but it's much more focused on energy and energy infrastructure, engineering, for example. So anyway, the weather, yes, is deeply important here, and has been always, because we're a very small island nation. We need the weather to grow our crops. We need the weather to, exist in a way that perhaps other people can get away with if things didn't change. But it's incredibly interesting, if nothing else, to talk about.
Weather and water and rain, and Joanne mentioned that we wanted to touch on this, are huge, huge topics that cover virtually everything, with an endless supply of stories to tell. And so for each of you, the question that's easy to ask is, how did you choose what to talk about and put down words in what order? How did you come about finding the themes, the way to organize, the route to writing your book? Are you still with us, Cynthia?
Maybe, I am, and it's
okay.
Yeah, so it's a great question, and it was so difficult. What was difficult was not figuring out what to put in, but not you know what I mean. Cutting. I had to cut so many things that I was just in love with, and maybe the most painful thing I cut were the chimpanzee rain dances that Jane Goodall has written a lot about. And in the end, and I think this is just my journalistic instinct, I tried to tell stories that hadn't been told so much before, that weren't so well known. So, for example, one of my favorite stories in the book, and when I went back to the proposal recently because a fellow science writer who's working on a book asked me if I would share my proposal. She wanted to see what a successful proposal looked like. When I read back over it, I saw that most of what I proposed did not end up in the book. I ended up including other things that felt the most new to me. And so, for example, one of my favorite stories is this story about the Indian village of Kanaj. It's a fragrance-making village where villagers make a rain perfume. And I thought that was a really beautiful story, and it's a story that had not been told, which was pretty remarkable. So it was, figuring out what to not chase. When you're a journalist, you just love chasing and pulling string and figuring things out, and you can spend days, weeks, and months and years chasing ideas. So the hard part was really narrowing that down, and I did it by asking myself, what are some of the lesser told stories that I should focus on? Because as we talked about earlier, this is an oversaturated market, pardon the pun. A lot of people have written water books, and a lot of people have written weather books. And so the key, as I think we've both tried to do, is to tell the story in a fresh way, and tell some new stories that maybe no one has heard before.
Well, as we move over to, as I make Alec answer this question, he wrote in his introduction something very useful that I wanted to be sure to share today. He wrote, "The human relationship to water is complex, multidimensional, and like a fractal, infinitely more intricate the closer you look. A single book could never hope to do justice to all of it. Fortunately, we've got two, and I don't think it's done yet. But anyway, we can see the whiteboard behind you, Alec, that you did organizing on. How did you organize all of these thoughts?"
Yeah, it's an interesting question. I was really fascinated to hear how Cynthia did it, because in many ways it mirrors what I did, almost not purposely. I'm a reporter. I sort of speak to people. I find interesting stories and I write about them. That's what I do. And I thought that writing a book would just be like doing that, but slightly longer. And it's actually nothing like that at all. It's really, it's almost like it's not even the same world of disciplines. It's like we're different planets in terms of what it involves. Because I think it took me a while to realize that. So I had a proposal in which I wrote essentially a list of things that I wanted to know and had found interesting. So the chemical weirdness, for example, I was clear in that proposal. I didn't want to write about water shortages, and I wrote in there because they are books and it wouldn't be treated properly here. And also, I read those books myself. I also wanted to do something that was filled with culture and history as much as it was filled with science. And I read many non-fiction books which, when they start dealing with science topics, like intricate science, some bit of chemistry or physics or something, they feel very unconfident with it. It's like it's a different subject. Yet they're fine with the politics and the history and all of those things. And I wondered if it was possible to write a non-fiction book which treated the history with confidence as well as the science with confidence, as if they're just different branches of knowledge. Yeah. And of course they are just different branches of knowledge. So that was my sort of forming thought, and I thought, go into it with that intention, and what do you find interesting? And then of course you immediately discover that you can write about almost every aspect of human society and history through water in some way, which is disastrous. It's a real disaster. And you think, how on earth am I going to make this into a story? And it took me a good I was about halfway or more through it, of collecting information and writing out stories and things. And I thought to myself, you know what? If I took a subject of water and someone else took the subject of water, we'd write two different books. And that's what you do. You just write whatever you think is interesting and has moved you in some way, because that is the only way you're going to move someone else. And picking the stories, picking the way you write it, picking the places you go, and your journey through that particular thing, that's what makes it your book, as opposed to a textbook about something. And so then I decided that every decision I made of saying, look, I find this interesting, but I just don't find this interesting, was fine. It's just that's the book I want to write. And in a way, that's a bit self-indulgent, because you've got to be thinking about who's going to read this and what do they want to know and stuff. And that's what a good editor is meant to whip you back with, and says, look, I just don't get this bit. Why is it there? And that's also helped shape it. But for me, the way I wrote it in the end, and again, was that as I went along, discovering things. I thought, this is quite interesting. I'll spend some time with this. If I find myself spending a lot of time doing something, I thought, probably someone else will find it interesting too.
Mm-hmm.
And then when I got to the stage where I had this one chunk of my proposal, which is all about history of civilization, essentially, which I've sort of very confidently written into my proposal. And I thought, you know what? I'm not sure I'm going to find this very interesting to write, so I just didn't. And then towards the end, there was one of my chapters was going to be about astrobiology, looking for water in space, and it was literally going to be half a chapter at the end of my book. In the end, I realized that I'd spent so much time finding this fascinating that it became 3 chapters, and it became a third of the book. And I think, and this sounds so trite, and every writer probably says this, but I discovered this book. I didn't intend to write it. I had an idea that it was going in some direction, but I discovered it as I wrote it, and I'm still really discovering it as I talk to you about it, if I'm honest.
So that's okay. Cynthia took care of the cultural history part of it for you.
Well, I'm glad.
Well, the other great parallel that I just realized is that I too put the formation of civilizations in my proposal. I had a tiny bit about astrobiology in my proposal, and I too became so enchanted after interviewing the astrobiologists. But also, as you know, I weave in fiction and Ray Bradbury when I talk about astrobiology. I too sort of really downsized ancient civilizations in favor of astrobiology and space. It really was fascinating, and again, something more new to look at.
And yeah, of course, it is new. I mean, it really is new, and that's why it's interesting, I think. Plus, also, I think that for me, it was enlivened by the fact that as I said, I went to a few days with the scientists at JPL and Ames near San Francisco, and just talking to those people and writing down what they say, almost with no extra editing, is anyone would find that interesting, and I found it fascinating. And in a way, I thought that was so much more enlivening than reading about some history of sociology about cities around rivers, which is also interesting and important, but because there's no characters there that I could immediately talk about. In a way, the astrobiology and the chemistry bits, because I'd spoken to these scientists myself, wrote themselves because of the people involved.
So the lesson I'm hearing from both of you, which may be one of many but is very useful, is that you need to tell stories that you find interesting, or else the reader's not going to find it interesting.
Oh, without a doubt. I mean, if you don't find it interesting yourself, you can't possibly hope that someone else will. I think that's fair to say.
I think that's another thing I talk to my students about too, Jeff. If you have an idea and you think to yourself, oh, this is important, I'm not thrilled about it, but this feels so important, I advise them to back off. You really want to be fascinated yourself in your topic, or not only does the reader suffer, but you really suffer through the writing if you're not absolutely gobsmacked by your topic.
And you have to want to tell somebody, even if it's just one person. Otherwise, it's again, it's just a textbook. One of my former editors at The Guardian used to say, and this is what I remembered all the time, is that news and journalism basically, and for me this book is journalism, the best way to describe it is it's like structured gossip, and gossip requires you to want to tell somebody else. It's okay. You basically, if you just want to know something, that's not necessarily a good journalistic story. That's fine. You want to know, that's education. But journalism is gossip. You have to want to also tell somebody else.
That's funny. A former guest on the show, Scott Hewler, who I hear from Jeff, has supposedly reviewed Cynthia's book, but he once told me, he said, to write a book, it's like you want to grab people by the lapels and say, you've got to listen about this. I've got to tell you about this. And he says that's the best way to write a book.
That's a great way to put it, yes.
Which is exactly why I haven't written one yet.
A fun read science fact, Joanne. Weren't we discussing this? And it's like we were talking about Cynthia's book, and I know that Scott Hewler said he was working on a review. It hasn't been published yet. And didn't we talk about Alec's book and find that Rose George had written about it? And so
yeah.
I was fascinated that the two of you would be talking with us today. And 2 years ago, we had a program when we talked to Rose and to Scott about their books.
Yeah.
And I think that's
it's
the
our
first time
yeah.
together. Yeah.
There's definitely something cosmic about that.
Very much.
Probably,
Very much.
probably. So, you know, and yeah, a great time. Their topic was sanitation, so a little bit about water, but in a slightly different way. So, of course, you're connected. So we have gone about an hour here, even with a late start, which is all good. I really enjoyed both of your books. I mean, it was definitely worth my time to read both of your books, and I enjoyed them, and so many things that are of interest in these books. I'm letting everybody in the audience know, just as a reminder, we've been talking with Cynthia Barnett about rain in natural and cultural history, and Alec's book, Water. What is your subtitle again?
The subtitle is the Extraordinary Story of Our Most Ordinary Substance.
Yes, that's a perfect subtitle, too.
Great.
And his book also has nice foil, shimmery colors.
It does. I wish we could see.
and yeah, so one day we will see it. Hopefully they'll keep that same cover in America. I think that's that would be really nice. So you never know. I always see different covers for the UK and US. But what we like to do at the end of our show is to actually ask our guests if there was anything else you wanted to add that we didn't touch on, that you would like to say to people thinking about reading your books.
Well, I think maybe we touched on this a little, Joanne, but I really see water and rain as unifying forces. I see water as a unifying force for humanity, right? And everything from, like we talked about, everything from religion to culture to science. And we're in a time, especially in the United States, of just a lot of conflict, a lot of snarkiness in conversation. And what I love about covering water and now writing a book of rain is that these are elements that bring us together. You know, rain literally brings us together. Like Alok talked about in the UK, it's a conversation starter. It's a way for complete strangers to have a really nice conversation, to be stuck somewhere and talk about rain. But I think it is also a unifying force in terms of coming to talk about climate change and sort of bringing us together. So that's the point I would make as a final point. I think this is a good connecting topic, and we need that so desperately in these divided times.
What I would add to that, I mean, there's so many things we could talk about when it comes to what water is and what it does, but I want to actually just extend what Cynthia says, which is that this is unifying. She talked about the world now, and I think it's unifying to all generations of human beings, from the very first human beings and first things. I mean, we Homo sapiens has existed on the earth for 200,000 years, or something like that, and those first human beings wouldn't understand your language. They wouldn't understand your customs. They would understand that you're human. Beyond that, you've got nothing in common except water. You know what it is, and they would know exactly what it is too. And it's not something different. It's like if they had some sort of food that you don't recognize. Yes, you have food that you both eat, but you don't recognize what it is. Water, you absolutely both know what that's for, and that's your connection with that person. And if you want to extend it to all other life too. And I think that looking into the future, this is also your connection with some life out there too. If life exists elsewhere, it might be formed from something else or use something else as a liquid medium to exist. But it's unlikely that it's water, because water is so common in the universe. It's simple, and it can already do these things. And we have to sort of force ourselves into weird shapes and situations to convince ourselves that something else would work in the same way. You can do that, by the way, but it's a little strange. So water is that thing that probably connects you to something else, and I think that's beautiful. This is your one connection to that creature that one day we'll discover somewhere on planet Zarg, a million billion light years away. This is probably it, you know. So just look at it slightly differently. That's what I say.
That's really a great way to end, both of you. Thank you so much to Alec and Cynthia for spending time with us today, and to our audience for joining us. And Jeff, as always, a pleasure to talk about science books with you all. And we'll see you guys next time on Read Science.
Thank you.
Thank you very much.
Bye.
Yep.
Thank you. All right. Bye.